Okay, Bismillah ar-Rahman ar-Rahim. We'll start this section 4.1, extreme and on interval. What we are talking about in this section. We're talking about the extrema. Extrema means what? The maximum and the minimum. So we'll define what's called absolute maximum, absolute minimum. Also, they call it global maximum, global minimum. It means what? You have a function defined in a domain. So in that domain, in all of the domain, we say f of c is the absolute maximum if f of c is the largest, if f of c greater than f of x for all x in the domain. And we say f of c is the absolute minimum in the kind f of c less than or equal f of x for all x in the domain. So f of c is the largest, we call it absolute maximum, the largest over the interval, over the full domain. And we call it absolute minimum if it is the smallest over the full domain. Also, we define what's called local maximum, local minimum. Just the same idea, but now I'll do it locally. So we'll take an open interval containing C and check containing C. Is there a value which is the largest over that interval? So f of C is greater than or equal f of x when x is near C, around C, from right and left, as like an open interval containing C. And this is the same thing, local minimum with kind f of c less than or equal f of x when x is near c. In the above definition, near c means what? Means that for all x in an open interval containing c, like what I did here. This is c, and I just I do open interval, I check is there a maximum minimum. That means also the endpoints cannot be local maximum nor local minimum, because the endpoints, I can define it to the right of C or to the left of C. I cannot do it for both. So we cannot discuss local maximum, local minimum at the endpoints. We have these theorems, these two theorems. It says what? If f is continuous on a closed interval, continuous on a closed interval, then for sure f has an absolute maximum and absolute minimum over that interval. It's called the extremum value theorem. We have the Fermat's theorem. It says what? If f has a local maximum or minimum at c, and f prime at c exists, then f prime at c equals 0. That means what? If f has a local maximum, local minimum, or we say relative, we call it local or relative, huh? Like global. Sometimes they call absolute or global or local or relative. So if f has a relative extremum, relative maximum, or relative minimum at c, then f prime is equal to 0, f prime at c equal to 0, or f prime does not exist. So this case, which is f prime is equal to 0 or f prime does not exist, we give it a name, which is we call it a critical number. And we add another condition. It's a number c in the domain of f. So I have c in the domain of f. This is number 1. 2, either f prime at c equals 0 or f prime at c does not exist. These are the two conditions for critical number. And this theorem, if f has a local maximum or minimum at c, for sure c is a critical number. So if f has a local minimum maximum at c, then c is what? A critical number of f. Then we said here, if f is continuous in a closed interval, then it has an absolute maximum and absolute minimum. This is the way to find the absolute maximum, absolute minimum, if I have a continuous function on a closed interval. We're saying how to do it. First, we find the critical numbers. Then we find f at the critical numbers. We find f at the endpoints, which is a and b. And then the largest will be the absolute maximum. The smallest will be the absolute minimum. Let us do examples. Just we'll do direct examples to be sure that we understand the topic. We'll use the graph below to determine the absolute and local maximum and minimum values. Okay, absolute minimum. Do we have an absolute minimum in this graph? Yes. Is there a value which is the smallest over all the interval? Yes, will be the smallest, which is what? 1, 2, 3, 4. So we have an absolute minimum 1 at x equal 4. The absolute minimum is the y value at x equal something. Do we have an absolute maximum? Someone maybe will say 5. No, 5 is not. This is not an absolute maximum. Why? Because I cannot say 5, the function is not defined there. So 0 and 5 is not a point in the graph. So we cannot say, you cannot give me a value which will be the largest over all the interval. If you give me 4.99999, just I will add 1. So it will be more than what you gave me. So you cannot give me a specific value where I can say this one is the maximum. So the absolute maximum, no, we don't have an absolute max. Now let me come to the local maximum. If you notice, this one is a local maximum. Why? Because if we take a value, this one is 3. If we take a value around 3, if we take an interval that contains 3, for sure, always will be a maximum. So I have a local maximum, 1, 2, 3, 4 at x equals 3. Also, I have another one here. This is also a local maximum. Take an interval containing, this is 6, this is 3, containing an interval around 6. For sure, this one will be the largest. So I have it 3 at x equals 6. Do we have a local minimum? Yes. If we do the same for this interval, for sure this number will be the smallest over that interval. So I have 2 at x equal 2. Is that the only one? No. Also this one, if we take it, which is 4, which is 1 at x equal 4. If we take an interval around 4, containing 4, then 1 is the smallest. 1 at x equal 4, which is the same as the absolute minimum. So 1 is a local and absolute minimum at x equal 4. Okay, now let us find the critical numbers. How to find the critical numbers? We said in the critical number in the domain of f, and f prime equals 0 and f prime does not exist. It means they need to find the domain and they need to find f prime. The domain of f is all real numbers, no restriction on x. X can be any value. So I need to find f prime. F prime will be what? 3 over 5 x to the power minus 2 over 5 times 4 minus x. This is the product. So derivative of the first times the second plus the first derivative of the second, which is minus 1. So that will give me what? X to the power minus 2 over 5 times 3 over 5 minus x minus x. Or you can check, multiply, you should get the one, the first, I mean the one in the first line. If you multiply, you should get the one in the first line. Okay, so now I just simplify this. That will be what? I have over 5, 12 minus 3x minus 5x over x to the power 2 over 5. In other words, This is 12 minus 8x over 5 x to the power 2 over 5. Okay, now we'll do f prime at c equals 0. F prime at c, it's what? 12 minus 8c over 5c to the power 2 over 5. That equal to 0. That implies 12 minus 8c equals 0. That implies c equal 12 over 8, which is 3 over 2. Is it in the domain of f? Yes, it's in the domain of f. Now we'll check f prime at c does not exist. Very clear. That means c equals 0. Is it in the domain of f? Yes, the domain of f is Orion. So what are the critical numbers? C equals 3 over 2 and c equals 0. We'll do more examples. Find the critical numbers for these functions. We'll do the first one. First, what is the domain of f here? Orion number. The domain of f, Orion number. The domain of f, Orion number. You have no restriction on x here. Here I have different domain. Domain of f will be 0 to infinity, where 0 is included. Here the domain of f from 0 to infinity, where 0 is not included. So it's an open interval. Number 4, I have a closed interval for the 0. Okay, number 1. What I will do, find f prime. F prime will be what? X cubed, yeah, minus 3x, which is, I can rewrite it as x squared minus 3. So f prime at c equal to 0. That implies c equals 0 or c equal plus square root of 3. The domain is Orion number, so this belongs to the domain of f. And this belongs to the domain of f. So what are the critical numbers? I have 3, c equals 0, and c equals square root of 3, and c equals minus square root of 3. Okay. Now number 2. F of x, 3x to the power 4 minus x to the power 6. The domain is what? Orion number. خلاص. So we'll find f prime. F prime will be what? F prime is 12x cubed minus 6x to the power 5. And that give me what? 6x cubed, which is 2 minus x squared. Need to find f prime equal to 0. That give me what? F prime at c. And usually you call it c to distinguish when finding the, yeah. To make it a critical number means at c. Okay. So I have from here very clear c cubed equals 0 or 2 minus c squared equal to 0. So that means c equal to 0 or c equal plus or minus square root of 2. So what are the critical numbers? C equals 0 or c equal square root of 2 or c equal minus square root of 2. Let me do number 3. Number 3, f of x equal 5 x to the power 2 over 3 plus x to the power 5 over 3. Domain is Orion numbers. Well, now we'll find f prime. Be careful there. It will be 10 over 3 x to the power minus 1 over 3. Just 2 over 3 minus 1 plus 5 over 3 x to the power 2 over 3. Now we'll take 5 over 3 times x to the power minus 1 over 3 as a common factor. What is the remaining? The remaining is 2. Check 10 over 3 x to the power minus 1 over 3 plus x. That's f prime at x. Now we need to check f prime. Yeah, by the way, in these cases, f prime exists for all x. So I did not discuss f prime does not exist. And the same thing here, f prime is defined everywhere. So I did not discuss f prime does not exist. In this case, no, it's different. So this one is equal to what? 5, 2 plus x over 3, x to the power minus 1 over 3. Okay, now we need to define f prime at c equals 0. That implies f prime at c. Let me write it in terms of c. That will be 5, 2 plus c over 3, c is 1 over 3, sorry. Yes, it's negative, I take it in the denominator, so this is 1 over 3. Okay, make it equal to 0. That implies c equal minus 2. This belongs to the domain of f. Actually, the domain of f is already a number, so no need to worry about this. F prime at c does not exist, and that implies c equals 0, which belongs to the domain of f. So what are the critical numbers? How many we have? 2. I have c equal minus 2 and c equals 0. Let me do number 4, which is f of x, x minus square root of x. The domain of f from 0 to infinity, including 0. So it's closed interval from at 0. I'll find f prime. That will be 1 minus 1 over 2 root x. And this one can be simplified. 2 root x minus 1 over 2 root x. Okay. Now, f prime at c equals 0. That implies f prime at c is what? 2 root c minus 1 over 2 root c equal to 0. So I have 2 root c minus 1 is equal to 0. So I have 2 root c equal to 1. Square both sides. So I have 4c equal to 1. So c equal 1 over 4. Is it in the domain of f? Yes. Now, I also need to check f prime at c does not exist. So very clear, square root of c is equal to 0, so c equals 0. Is it in the domain of f? Yes. So what are the critical numbers? C equal 1 over 4 and c equals 0. Let me do the next one. I have f of x, number 5. F of x equal x ln x. Note the domain here is what? From 0 to infinity, where 0 is not included. Okay, f prime. The derivative of the first is 1 times ln x, and that will be ln x, plus x times 1 over x, so the answer is 1 plus ln x. F prime at c, that will be 1 plus ln c equal to 0. So I have ln c equals to minus 1. Take a of both sides. That means c is 1 over a. This one is positive. So it belongs to the domain. That belongs to the domain of f. If we discuss f prime does not exist, then when f prime does not exist, which is the same as defined of len, where x is non-positive, which is not in the domain of f. So no need to discuss that. So what are the critical numbers? C equal 1 over a. We have only one critical. Let me do examples to find the extrema. We said, as before, how to find the extrema. I have these steps. First, check if f is continuous over a closed interval. Then I find the critical numbers. I find f at the critical numbers. I find f at the endpoints. The largest will be the absolute maximum. The smallest will be the absolute minimum. Let us do it. We start by a simple example. F prime is what? 12x cubed. Or first, before that, we say F is continuous on that interval. Actually, the function F is continuous everywhere. But I should specify إنه F is continuous over a closed interval. Then I find F prime. That will be what? 12x cubed minus 12x squared. Okay. Then I take 12x squared common factor. The remaining is what? X minus 1. So to find the critical numbers, I need to check F prime at C, which is 12c squared. C minus 1 equal to 0. Very clear. I have C equal 0 or C equal 1. Is there a need to discuss if prime does not exist? No. If prime exists everywhere. And I need to check one thing also. 0, is it in the interval? Because I'm talking about specific interval. And 1 also in the interval. So I need to check these values are in the interval. So now I'll find F at 0, F at 1. Then I check F at the endpoints, F at minus 1, F at 2. Okay, F at 0, 0. F at 1, it will be 3 minus 4, which is minus 1. F at minus 1, it will be 3 minus 4 times minus 1, and that will be 7. F of 2 will be what? 3 times 16, and that is 48. 4 times 8, 32, and that give me 16. So this is absolute maximum, and this is absolute minimum. Can summarize, absolute maximum is 16 at x equal to, and absolute minimum is minus 1 at x equal. Okay. Find extreme over this function over this interval. But the function is continuous everywhere. We have no problem, cubic root. So I need to specify f is continuous over this on this interval. It means it has an absolute maximum, absolute minimum. We'll find f prime. F prime will be what? 2 minus 2 x is minus 1 over 3. And that will be 2, 1 minus 1 over cubic root of x. That will give me 2 cubic root of x minus 1 over cubic root of x. Okay. Now, f prime at c will be 2 cubic root of c minus 1 over cubic root of c equal to 0. I have cubic root of c minus 1 is equal to 0. I have cubic root of c equal to 1. So c equal to 1. If prime at c does not exist, for clear, c equals 0. Is this one in the interval? Yes. Is this one in the interval? Yes. So I will consider. So I need to check f at 1, f at 0, f at the endpoints, f at minus 1, f at 3. Let's do it one by one. F at 1 will be 2 minus 3, and that is minus 1. F of 0, 0 minus 0, 0. F of minus 1, that will be minus 2. Minus 1 squared, that is 1. Cubic root, that is 1. So minus 2 minus 3, and that is minus 5. F of 3 will be 2 times 3, which is 6, minus 3 times cubic root of 3 squared. That will be cubic root of 9. This number, is it positive or negative? How to check? I need to check cubic root of 8. I know that in the cubic root of 8 is 2, which means in the cubic root of 9 will be greater than 2, since it's greater than cubic root of 8. So this is greater than 2. 3 times something greater than 2, that will be greater than 6, so this will be a negative value. So this will be the absolute minimum. No. This will be the absolute maximum. This is negative, negative, negative. So 0 is the largest, and minus 5 is the absolute minimum. So I have absolute maximum 0 at x equals 0, and the absolute minimum is minus 5 at x equals minus 1. So sometimes to decide which one is the largest, which one is the smallest, you need to be careful. Okay. Let me do more problems to find the extrema. Yeah. This function. First, f is continuous over the closed interval, very clear. F is continuous on this interval. Then I'll find critical numbers. How to find the critical numbers? This is we'll find the critical numbers. Okay. How to find the critical number? We'll find the derivative. That will be what? 2 cosine x. I have minus cosine to it. Derivative of cosine to x is minus 2 sine to x. So that will be plus 2 sine to x. What is sine to x? Is 2 sine cosine. So this will be 2 cosine x plus 4 sine x cosine x, where I can take cosine x as a common factor, 2 cosine x, I can take it as a common factor. The remaining is 1 plus 2 sine x. Okay. Now if prime at c equal to 0, so that implies 2 cosine c times 1 plus 2 sine c equal to 0. So I have cosine c equal to 0 or sine c equals minus 1 over 2. Okay. And I have it just in one cycle from 0 to 2 pi. Cosine c equals 0. So that means c equal pi over 2 and 3 pi over 2. Sine c equal minus half, which is which quadrant in this? Minus half is in the sine is negative, third and fourth. And the reference angle for half is pi over 6, 30. So this will be pi plus pi over 6, which is 7 pi over 6. And 2 pi minus pi over 6, which is 11 pi over 6. So these are the angles. And these are in the interval. Huh? Actually, I looked them for this interval. Okay, so I need to check now f of pi over 2, f of 3 pi over 2, f of 7 pi over 6, f of 11 pi over 6, and also the endpoint f of 0 and f of 2 pi. Okay, f of pi over 2 will be what? Sine pi over 2 is 1, so that will be 2. Cosine by 2 times pi over 2, that is cosine pi, which is minus 1, so it's 2 minus minus 2 minus minus 1, that will be 3. F of 3 pi over 2, sine will be negative now, so that will be minus 2. And then I have cosine 3 pi, which is also negative, so it's minus 2 minus 1, and that gives me minus 1. Okay, if 7 pi over 6, I know sine is minus half, so that will be 2 times minus half minus. Now if x is 7 pi over 6, what will be cosine to x? It will be cosine 7 pi over 3. 7 pi over 3 is what? 2 pi plus pi over 3. So it will be quadrant 1. Cosine pi over 3, that will be half. So it's 2 times minus half cosine 60, which is half. It's 2 minus half. And that gives me minus 3 over 2. Minus 1 minus. Okay. If 11 pi over 6, the same. But when it comes to x equal 11 pi over 6, so cosine to x will be what? It will be cosine 11 pi over 3. Where is 11 pi over 3? I know 12 pi over 3 is 4 pi, which is a complete cycle, 2 cycles, complete 2 cycles. So 11 pi over 3 will be the fourth quadrant. So still this is half. So this is will give me the same value, which is minus 3. If at 0, quickly, it will be 2 sine 0, 0, minus 1. So this is minus 1. If at 2 pi, I know sine 2 pi is 0 and cosine 4 pi is 1. So that will give me minus 1. So very clear, this is absolute maximum. And these are the absolute minimum. So I have the absolute minimum. I have one absolute minimum, but at 2 different values. So I have absolute maximum is 3 at x equal pi over 2. And I have absolute minimum is minus 3 over 2, but at 2 different values. At x equals 7 pi over 6, and x equal 11 pi over 6. Okay. But I have only one absolute minimum. I cannot have 2. Find the absolute maximum for this function. So first I need to state in f is continuous on this closed interval. Okay. Now we need to find the critical numbers. Find the derivative. So you have 3x squared minus 6x, and that gives me 3x, x minus 2. So f prime at c equals 0, that implies, make it like this quickly, 3cc minus 2 equals 0. So you have c equals 0 or c equal 2. Is it in the interval? Yes. Is it in the interval? Yes. So we'll take them. By the way, we did not discuss in all of these examples. In this example, f prime does not exist because actually f is defined. If f prime, the function is differentiable everywhere. So in the closed interval, that interval also is differentiable. Okay. So now I have, these are the points I want to check. F at 0, f at 2, also the endpoints. F at 0, check 0 minus 0 plus 1, that is 1. F at 2 will be what? 8 plus 1, 9 minus 12, that is minus 3. F of minus half, that will be minus 1 over 8 minus 3 over 4 plus 1, and that will be what? 1 minus 7 over 8. Yeah, 3 over 4 is 6 over 8, so it's minus 7 over 8. And that gives me 1 over 8. A1, you can consider it 8 over 8. F at 4, that will be 64. 4 squared is 16 times 3 is minus 48 plus 1. That will be 65 minus 48, which is 70. So very clear, this is absolute maximum. And this will be the absolute minimum. So conclusion, absolute maximum 17 at x equal 4. Absolute minimum minus 3 at x equal 2. Okay. I will do more examples. Find absolute maximum, absolute minimum. This function. So first we need to specify f is continuous on this closed interval. So check critical numbers. We'll find f prime. It will be 1 minus 2 cosine x. Okay. Now we need to check f prime at c, which is 1 minus 2 cosine c. Make it equal to 0. That means cosine c equal to half. And that happen. I have one full cycle. Cosine equal half. It means positive. So it's the first and fourth. And the reference angle is pi over 6, pi over 3, 60. So it's equal pi over 3 and 5 pi over 3. In the fourth quadrant is 2 pi minus the reference angle. So it's 5 pi over 3. Okay. Now I'll check f of pi over 3, f of 5 pi over 3. Also check the endpoints, f of 0, f of 2 pi. Yeah. F of pi over 3, it will be pi over 3 minus 2 sine 60, which is square root 3 over 2. That can be pi over 3 minus square root of 3. And this one will be 5 pi over 3 minus 2 sine 5 pi over 3. That's in the fourth quadrant. That will be minus square root 3 over 2. So it will be 5 pi over 3 plus square root 3. Okay. At 0, 0 minus 0, that will be 0. At 2 pi, it will be 2 pi. Sine 2 pi is 0, so it will be 2 pi. They need to check which one is bigger, which one is smaller. First, I notice pi over 3 approximately is 3.14 over 3. Square root of 3 is approximately 1.7. Very clear for me, square root of 7 greater than pi over 3. Okay, so that means this is a negative value. And not only that, also if we check 2 pi and make it 5 pi over 3 plus pi over 3, so which is bigger? I know the square root of 3 is bigger, so that can be the absolute maximum. Since this is bigger than this one, and this one will be the absolute minimum. Why? Because this is negative, so it's smaller than 0. Conclusion, absolute maximum is 5 pi over 3 plus root 3 at x equal 5 pi over 3. Absolute minimum, pi over 3 minus square root of 3 at x equal pi over 3. Okay. Now let me do these problems. Okay. First, I specify f is continuous on this interval. Find the critical numbers. I specify this for sure. I have an absolute maximum, absolute minimum. Okay. So I'll find f prime. That give me what? 3x squared minus 3. Correct? Yeah. That will be 3x squared minus 1, which is 3x minus 1 times x plus 1. F prime at c equals 0. F prime at c will be what? 3 c minus 1, c plus 1 equal to 0. So I have c equal 1 or c equal minus 1. Be careful here. This one is in the interval, which I'm working on it. This one is not in the interval, so I will not consider over this interval. So I will check f at 1 only from the critical numbers group, and I'll check the endpoints, f at 0, f at 3. F at 1 will be what? 1 plus 1 minus 3 minus 1. F at 0 will be 1. F of 3 will be 27 minus 9 plus 1. That give me what? 19? Yes, that give me 19. So very clear, this is the absolute maximum, and this is the absolute minimum. So conclusion, absolute maximum is 19 at x equals 3, and absolute minimum is -1 at x equals 1. 2. This is the function. If it's continuous, actually continuous everywhere, since there's no restriction on x. Cannot be 0. X squared plus 4 cannot be 0. So we'll find f prime. That will be what? The derivative of the numerator, which is 2x times the denominator, and the derivative of the denominator, which is 2x times the numerator, over the denominator square. That give me what? 2x cubed minus 2x cubed, مع السلامة. 2x times 4, 8x minus 2x minus 1, that will be 16x. Over x squared plus 4 squared. F prime at C, this is to find the critical numbers. F prime at C will be what? 16c over x over c square plus 4 square. Equal to 0, that means c equals 0. Is it in the interval? Yes. And F prime cannot be, a function is differentiable everywhere. A prime always exists. So check f at 0, and f at -4, and f at 4. F at 0, give me what? -4 over 4, which is -1. F at -4, give me what? 16 minus 4 over 16 plus 4. That will be what? 12 over 20 divided by 4. That give me 3 over 5. And the same thing here. It will be 16 minus 4 over 16 plus 4, which is 3 over 5. So I have absolute maximum at 2 different values. And this will be the absolute minimum. So conclusion, absolute maximum is 3 over 5 at x equal -4 and at x equal 4 at 2 different values. Absolute minimum is -1 at x equals 0. Okay. Next one, this is the function, which is sine x plus cosine x, which for sure continuous. What's the interval? Over this interval 0 and pi over 3. Okay, f prime will be what? Will be cosine x, to find the critical numbers, minus sine x. Okay. So I need to check f prime at c, which is cosine c minus sine c equal to 0. So I need to check when cosine c equals sine c. And that for sure give me what? C equal pi over 4, since it's in the first one. And it belongs to the interval. Once I check f of pi over 4, I check f at 0, I'll check f at pi over 3. Okay, f of pi over 4 will be what? Root 2 over 2 plus root 2 over 2, which is root 2. F of 0 will be 0 plus 1, and that is 1. F of pi over 3 will be root 3 over 2 plus half, and it's root 3 plus 1 over 2. The smallest value is 1, for sure. This is greater than 1, and this is greater than 1. So this is the absolute minimum. Hmm. But which is bigger? Which is bigger? Square root of 2 or x1 square root of 2 or x2 root 3 plus 1 over 2? One way to decide about it, since the values are positive, I can square both of them. So I have x1 square is 2, but x2 square is what? Root 3 plus 1 square over 4. And that will be 3 plus 2 root 3 plus 1 over 4. And that will be 4 over 4 plus 2 root 3 over 4, and which is equal. So that implies into x2 is what? 1 plus root 3 over 2. Root 3 over 2 is less than 1. So this is less than 2. So that means this will be the absolute maximum. So that means x2 square. That means x1 greater than x2. So conclusion, I have absolute maximum root 2 at x equal what? 5 over 4, and absolute minimum 1 at x equals 0. Okay. Yeah, number 4. F of x equal then x over x, which is continuous over this interval. What is the interval? 1 and 3. Yeah, the interval 1 and 3. Okay. So we'll find critical numbers. We'll find f prime. Derivative of the numerator, which is 1 over x times x, that is 1, minus derivative of the numerator, denominator, which is 1 times ln x, which is 1 minus ln x over x squared. So I need to find f prime at c, and it's 1 minus ln c over c squared. If you make it equal to 0, I have ln c equal to 1, so c equal what? E, which is belongs to the interval 1 and 3. So we are okay. Now, c belongs to the interval. So I need to check f at e. By the way, f prime does not exist at x equals 0, which is not in the interval. Actually, it's not in the domain of f. So, yeah, the domain is, yeah. So no need to discuss f is not differentiable. So I need to check f at e and f at the endpoints, f1, f3. F of e will be what? 1 over e. F of 1 is 0. F of 3 will be ln 3 over 3. This is positive. This is positive. So it means this is absolute minimum for sure. The difficulty is how to define, how to check 1 over e with respect to ln 3 over 3. I think it's very complicated. And by the calculator, this is point 348, something like this. 368, I think. 368. Check it again. And this is 0.366, which is very near to each other. I don't think it's easy to check which one is bigger. So for sure, will be the absolute maximum. Yeah. So I have absolute maximum 1 over E at x equal E, and absolute minimum is 0 at x equal 1. Okay. Now I'll finish the examples which explain the topic, which are from the note. Now I will go to the problems, or I'm getting it from the quizzes of the coordinator. Okay. So find the absolute maximum, absolute minimum for this function. The function is continuous everywhere. This is the first things we need to specify over this interval. So find the critical numbers. F prime at x, derivative of x, which is 1. So I have x squared plus 1 minus x times 2x over x squared plus 1 squared. And that give me what? X squared minus 2x, that's going to be 1 minus x squared over this. In other words, this is 1 minus x, 1 plus x over this. We check f prime at c, which is 1 minus c, 1 plus c over c squared plus 1 squared equal to 0. So I have c equal 1 or c equal minus 1. Be careful. This is in the interval. This one does not belong to the interval, so I will not check. So I need to check only f at 1, f at 0, f at 2. F at 1, check 1 over 2. F at 0, 0 over 1, which is 0. F at 2 will be 2 over 5. Which is bigger, half or 2 over 5? It's very clear half is bigger, but I can be sure. Multiply by 5 over 5. That give me 5 over 10. Multiply by 2. That give me 4 over 10. So very clear. This is the absolute maximum, and this is the absolute minimum. The conclusion, absolute maximum is half at x equal 1. Absolute minimum is 2 over 5. No, 0 at x equals 0. Okay, next one. Now the function, what is the domain of f first? Domain of f, I want this is greater equal to 0. So x less than or equal to 1. So yeah, this is including the domain. So we'll say the function is continuous on this interval. So I need to find the critical numbers. How to find the critical numbers? Derivative. F prime at x, be careful. Derivative of x, which is 1, times root 1 minus x, product rule, plus x, derivative of this, 2 root 1 minus x, derivative of this, which is minus 1. So that give me what? Simplify 2, 1 minus x over 2 root 1 minus x. And that give me 2 minus 3x over 2 root 1 minus x. Okay. I have f prime at c equal to 0. F prime at c is what? 2 minus 3c over 2 root 1 minus c. Make it equal to 0. That means c equal to over 3. Is it in the interval? Yes, it's in the interval. F prime does not exist. That implies no c equal to 1. But yeah, actually the critical numbers, it will be considered as a critical number because it is the domain of the function. Critical numbers are c equal 2 over 3 and c equal 1. But when I do the calculation, I'm getting the one from the endpoints. No need to check the endpoints. I mean, no need to find the endpoints through the critical numbers, because I will check it at the end. F2 over 3, that will be f of minus 1, f of 1. I mean, this can be checked through two things, the critical and the endpoints. But when we find the critical, usually we find the absolute maximum, absolute minimum, just will do that at the inner interval. Since the endpoints, I will check it for sure. So I have f2 over 3, that will be 2 over 3, square root 1 over 3. And that will be 2 over 3 root 3. F of minus 1, that will be minus square root of 2. Okay. F of 1 will give me 0. This is positive for sure. So this is absolute maximum. And this is absolute minimum. So the absolute maximum is 2 over 3 root 3 at x equal 2 over 3. Absolute minimum minus square root of 2 at x equal minus. Yeah, we have different functions you need to deal with. Yeah, I'll try to reach this one. Find absolute maximum to know for this function. No, the function is continuous everywhere. For sure, it's continuous on this interval. So to find the critical numbers, you need to find the derivative. Be careful. Product rule. Derivative of x is 1 times the second one plus x times derivative of this, which is e minus x squared over 8 times derivative of this, which is minus x over 4. 2x over 8, which is x over 4. Okay. This is I can take e minus x squared over 8 as a common factor. What's the remaining? 1 minus x squared over 4. And that will be 1 over 4 a minus x squared over 8. 4 minus x squared. Okay. Which is, I can rewrite it as 4 minus x squared over 4 ax squared over 8. So I have f prime at c, which is 4 minus c squared over 4 e c squared over 8. Make it equal to 0. So I have c equal 2 or c equal minus 2. Be careful. This is in the interval, but this is not in the interval. And if prime does not exist, no, if prime always exists, and this is cannot be 0. So I'll need to check f at 2 and the endpoints, f at 0, f at 4. F at 2 will be what? 2 e minus half, correct? Minus 4 over 8, which is minus half. Another word, minus 2 over root e. F of 0 is 0. 0 times e to the power 0 times 1, which is 0. F of 4 will be 4 e minus 2. And that will be 4 over e squared. Which one is bigger? And for sure, this one will be greater than 1. E is 2.7 under the square root. It will be 1 point something. 2 over, that will be greater than 1. And this is will be less than 1. So this is will be an absolute maximum. And this is will be absolute minimum. By the way, this is positive and this is positive. These two values are positive. So 0 is the absolute minimum. So I have absolute maximum 2 over root e at x equal to, and I have absolute minimum 0 at x equal 0. Sometimes to decide the maximum minimum, you need to do some calculation. You need to do some tricks or check. You need to check it, yeah, easily. I think we did this, but not over that interval, over another interval, 0 to 2. Okay, so we'll do it again. So first we need to specify that if it's continuous on this interval, which is true. Now we need to find critical number, we need to find f prime. F prime, I think we did before. Yeah, f prime, what? 1 minus x over 1 plus x over x squared plus 1. It's 1 minus x, 1 plus x over x squared plus 1 squared. So f prime at c will be 1 minus c, 1 plus c over c squared plus 1 squared. Make it equal to 0. So you have c equal minus 1 or c equal 1. As the critical numbers, I have c equal minus 1 and c equal 1. For sure, these are the critical numbers. But when I check, actually, I'm getting it from the endpoints. So no need to get it also from the, so just get it one time. F of minus 1, f of 1. That's what I need to check. That give me what? Minus half, and this is give me half. So for sure, this is absolute minimum, and this is absolute max. So I have absolute maximum is half at x equal 1. Absolute minimum is minus half at x equal minus. Okay. Now, this is a question about the critical numbers for this function. First, what's the domain of f? All real numbers. The domain of f is all real numbers. Okay. So I need to find f prime. That will be e sine 2x times what derivative of sine 2x? 2 cosine 2x. Very clear, f is differentiable everywhere. So just to check, I need to check f prime at c equals 0. So that gives me cosine 2c equal to 0. When cosine 2c equal to 0, that means 2c equal pi over 2 plus n pi, which is pi over 2, 3 pi over 2, 5 pi over 2, and so on, where n actually 0 plus or minus 1 plus or minus 2, etc. So I have c is pi over 4 plus n over 2 pi, where n 0 plus or minus 1 plus or minus 2, etc. These are the critical numbers. So I have infinitely many critical numbers. This one I did before, no need to do again. This is the graph of a function that has an absolute maximum, but not absolute minimum. Oh, okay. That means what? That means f is not continuous. Because if it is continuous, it should have an absolute maximum, absolute minimum. He said they want the graph of a function where it has an absolute maximum but no absolute minimum. I can do sketch. And by the way, there is no one. There are many answers. Okay, just check from 1 to 4. So take a point here. Let it go up until 1 point. Oh no. Go up until something and go down. Then this one make it open. Or I can do it like this. Yeah, because I want it to be open here. And then make the function starting from what? There. Do something like this until 4. So for sure, this is an absolute maximum, but no absolute minimum. Because they make it not continuous at this point. So just a sketch of a graph. There are many ways to do it, but this is the idea. I need the function to be not continuous. Find the critical numbers of this. What are the domain of f? All real numbers except 0. This is I have a negative exponent. Okay, so I need to find f prime. F prime will be 1 over 3, x to minus 2 over 3, minus 2, x to the power minus 5 over 3. I take x to the power minus 5 over 3, common factor. What I have? 1 over 3, x minus 2. Okay. And this is can be what? I can take 1 over 3. We do it in steps. X minus 5 over 3. I have x minus 6 over 3, which I can write it x minus 6 over 3, x to the power 5 over 3. Okay. Now to check the critical numbers, I need to check f prime at c, which is c minus 6 over 3, c to the power 5 over 3, equal to 0, then c equals 6. Is it in the domain of f? Yes, in the domain of f, since the domain is only number except 0. So c equals 6 is a critical number. F prime at c does not exist. That means c equals 0, but this is not a critical number, but does not belong to the domain of f. So the only critical number I have is c equals 6. Okay. Find the absolute maximum, absolute minimum of this function over this interval. First, I need to specify if it's continuous, actually continuous everywhere, but I need to be sure it's not continuous over the closed interval. Okay. I need to mention this. So I need to find the critical numbers. So I'll find f prime, and that will be what? Yeah, that will be cosine x. Cosine is derivative minus sine, cosine x plus sine x. I need to check f prime at c. Basically, the function is differentiable everywhere, so no need to check when f prime does not exist. Huh? So prime of c, that will be cosine c plus sine c. Make it equal to 0. So I need cosine c to be minus sine c. So I need cosine and sine. They agree, but they have different signs. I have that will happen. I have only the first and the second quadrant. So for sure that will happen in the second quadrant. And my reference angle is pi over 4. So that means C is 3 pi over 4. Okay. Now we'll check F at 3 pi over 4. Also check F at the endpoints. F3 pi over 4 will be what? I have sine 3 pi over 4, and that root 2 over 2. Cosine 3 pi over 4, second quadrant, that minus root 2 over 2. So the answer is root 2. Yeah, you can do it in 2 steps. Root 2 over 2 plus root 2 over 2, and that root 2. If at 0, it will be sine 0 minus 1. That will be minus 1. If at pi, sine pi, which is 0, minus 1, that will be 1. So for sure, this is an absolute minimum. And I know the square root of 2 is greater than 1. So this is absolute maximum. Conclusion, absolute maximum, square root of 2 at x equals 3 pi over 4. An absolute minimum, minus 1 at x equals 0. Yes, now we start this group of problems where I have multiple choice. Okay. They want the absolute maximum only. They want the absolute maximum. Okay. I know the function is continuous. Actually continuous everywhere. So continuous in this interval. 0 to pi over 6. Closed interval. Find the critical number, same idea. F prime will be what? it will be 4 cosine 2x minus 4 sine 4x. I want to make this similar to this one. So I'll make it 4 cosine 2x minus 4, 2 sine 2x cosine 2x. Since this is the double angle of this is 2 times 2x. So I can compare these two. So I can take 4 cosine 2x as a common factor. The remaining is 1 minus 2 sine 2x. I check f prime at c equal to 0. So I have cosine 2c equal to 0 or sine 2c equal to half. Cosine 2c equal to 0, that means c equal 2c equal pi over 2. So c equal pi over 4, which is not in the interval. Okay. Actually, if also we do it with n, it will be the same, huh? I mean, if we make it 2c equal pi over 2 plus n pi, so c equal pi over 4 plus n over 2 pi. If n equals 0, I have pi over 4. If n is negative, then it will be negative. It's not in the interval. If n equal 1, then for sure it's not in the interval. So no value will make it in the interval. For this, I have 2c equal pi over 6. That's the only interval I'm getting. So c equal pi over 2. Okay. Or otherwise, if I wanted the second one, 5 pi over 6, that will be 5 pi over 12, which is not in the interval. Okay. So I need to check f at pi over 12, f at 0, f at pi over 6. Let me do it one by one and be careful. 2 sine pi over by 2 times pi over 12. This is pi over 6. Sine pi over 6 is half. It will be 2 times half. Cosine 4x. So if x equal pi over 12, cosine 4x is cosine what? 4 pi over 12 pi over 3, and that is half. So it will be 2 times plus half, and that will be 3 over 2. Okay. If at 0 is easy, sine 0 is 0, and cosine 0 is 1, that will be 1. Pi over 6, it will be sine pi over 6 times 2, that's pi over 3. Sine pi over 3 is square root 3 over 2. So that 2 is square root 3 over 2. Cosine 4x. If x equal pi over 6, what will be cosine 4x? It will be cosine 2 pi over 3, which is in the second quadrant. So cosine is negative. And the reference angle is pi over 3. So that gives me minus half. So that gives me square root of 3 minus half. So for sure, will be the absolute max. So this is 1.7 minus 0.5, which is 1.2, and this is 1.5. So 3 over 2 is my answer. I want this the absolute maximum. The number of critical number. It doesn't want what are the critical number. How many we have of these critical numbers? How many critical numbers we have? Okay. First, I need to find the domain of f. This one I can rewrite it. 1 over cube root x minus x cubed. So what's the domain of f? I need this. Find the domain of f. I need x minus x cubed, which is x 1 minus x squared, which is x 1 minus x 1 plus x. This is not equal to 0. So the domain of f all real numbers except 0, minus 1, and 1. Okay, now let me find f prime. What will be f prime? Will be minus 1 over 3, x minus x cubed to the minus 4 over 3. Derivative of this, 1 minus 3x squared. So I can rewrite it as 3x squared minus 1 over 3x minus x cubed. Or you can make it cubic root. Cubic root all to the power. Okay, f prime at c equals 0. That implies 3c squared minus 1 equal to 0. So I have c squared is equal to 1 over 3. That means c equal plus minus 1 over square root of 3. And all of them, they belong to the domain of f, since they are not one of these values. F prime of c does not exist, implies c equals 0, c equal 1, c equal minus 1, but I will not take any one of these. Why? Because they are not in the domain. Does not belong to the domain of f. So how many critical numbers we have? Critical numbers are c equal 1 over square root of 3 and c equal minus 1 over square. How many are they? 2. Original functions has no absolute maximum. No absolute maximum in the closed interval. If the function is continuous in a closed interval, it has an absolute maximum. So you should avoid the continuous function. This is continuous, so for sure it has an absolute maximum. This is wrong. This is continuous, wrong. This is continuous, wrong. I'll go to B. B is easy to graph. So I have at x, I need to do it between minus 1 and 1. Huh? Between minus 1 and 1, just over this interval. Let's see. When I graph the function, does it have an absolute maximum or not? If I have, if x is negative, it's minus 1. If x is negative, it's minus 1. So it means it's something like this. This is open, this is minus 1. If x is positive, it's 1. If x is positive, it's 1, and it's open here. Does it have a maximum? Yes, very clear. 1 is an absolute maximum. So this is wrong. Now A, let me graph it too. And also the same thing. I want it to be minus 1 and 1 over this interval. If x is negative, it's x. So it will be something like this. But it's open here. This is minus 1. Okay. If x is greater than or equal to 0, it's minus 1. It's minus 1 here. Up to here. Is there a local, is there an absolute maximum? No. 0 is not an absolute maximum. So no absolute maximum. So this is my answer. The sum of the critical numbers of this. 4 problems to go. I need to check the function. What is the domain of f? 4. Now we'll do the derivative. Be careful. That will be what? 1 over 3 x plus 1 to the power minus 2 over 3. Product rule. Derivative of this times the second plus the first. Derivative of the second, which is e to the power x. Now we'll take e to the power x times x plus 1 to the power minus 2 over 3 as a common factor. I have 1 over 3 plus x plus 1. That give me what? This is, yeah, ex over this. And here I have what? 1 plus 3x plus 3 over 3. And that will be what? ax 3x plus 4 over 3x plus 1 to the power 2 over 3. That will be f prime. So f prime at c equals 0. Give me what? E to the power c cannot be 0. Give me 3c plus 4 equal to 0. So c equal minus 4 over 3. Is it the domain of f? Yes. Actually, the f is Oriental, so it's in the domain of f. F prime at c does not exist. That implies in x, that implies in c equal minus 1. Is it in the domain of f? Yes. The domain of f is all real numbers. So what is the sum? Is minus 4 over 3 minus 1, and that will be minus 7 over 3, which is this. Okay. The absolute maximum of this function over this interval. Interval is very complicated. Strange a little bit, and the function too. Okay. So, but we need to find the absolute maximum. Okay. So the function is continuous in this interval, in this closed interval, very clear. Okay, I need to find f prime, to find the critical numbers. I need to find f prime. That will give me what? Yeah. Okay. Derivative of the numerator, and that will be 1 over 5x times 5 times the denominator minus 2x ln 5x over x to the power 4. This is 5 constant, so I have x, common factor, 1 minus 2 ln 5x all over x to the power 4. In other words, it's 1 minus 2 ln, this is not an absolute, 5x over x cubed. The domain, yeah, this is the domain I'm talking about, 1 over 5, 8 to the power 5. Okay. So I need to check f prime at c equal to 0. That implies 1 minus 2 ln 5c equal to 0. That implies in 2 ln 5c is equal to 1. Correct? Yeah. So that implies what? Ln of 5c equal to half. Take a of both sides, so that means 5c equal e to the power half. That implies c equal root e over. What about if prime does not exist? That means x equals 0, which is not in this interval, actually not in the domain of the function. So I will not consider. So I need to check f at root e over 5, f at 1 over 5, e over 5. Yeah. If root e over 5, that will be ln root e over e over 25. Ln of root e, that will be half over e over 25, and that give me half times 25 over e, and that 25 over 2e. Okay, 1 over 5, so ln 1, which is 0 over 1 over 5 squared, that will be 0. E over 5 has ln e, which is 1 over e over 5 squared. And that will give me 25 over e squared. I know e squared is greater than 2e. That implies 1 over e squared less than 1 over 2e. That implies 25 over e squared less than 25 over 2e. So this is my absolute maximum. But this is bigger than this. And for sure, greater than 0. So the absolute maximum is this. The set of all critical numbers. You need to find the critical number. Domain of F or real numbers. Yeah, almost there. So you need to find F prime as theta. And that will be minus 2 sine theta plus 2 sine cosine. Okay. I'll take 2 sine common factor. The remaining is what? Minus 1 plus sine theta. So we need to check F prime at C equals 0. That implies no sine C equals 0 or cosine C equal 1. Cosine C equal 1. So C is what? C are what? 0, 2 pi, 4 pi, and the negative part. Okay. Sine C is equal to 0. So C is what? 0 by 2 pi, 3 pi, and so on, and the negative side. So for sure, these included here. Huh? So these values are included in this one. So I can write C or what? Or the n pi, so that n is an integer. So this is my answer. Find equal capital M, the absolute maximum. Small m, the absolute minimum. He wants us to find that. F is continuous actually everywhere. So it's for sure continuous in this interval. Find F prime. That will give me 6x squared minus 6x minus 12. So I can take 6 common factor. I have x squared minus 6 minus 2. And that will be 6. Let's define the critical number. X minus 2, yeah, times x plus 1. F prime at C equal to 0. That implies C equal to or C equal minus 1. Is it in the domain? Yes. Is it in the domain? Yes. So I need to check these 4 points, f of 2, f of minus 1, and the endpoints, f of minus 2, f of 3. Okay, let us do it step by step. F of 2 will be what? 2 times 2 cubed, that will be 16. 2 square, 2 square is 4. That will be minus 12, minus 24. And that will be what? Yeah, minus 20. That will be minus 20. Okay. 2, 4, yes. Minus 36, 16 minus 36, that's minus. F of minus 1, that will be minus 2, minus 3, plus 12, and that is 7. F of minus 2, that will give me 2 times minus 8, that is minus 16, minus 3, minus 12, plus 24. That gives me what? 28, minus 28 plus 24, that will be minus 4. F of 3, 3 cubed is 27 times 2, that will be 54, minus 3 times 3 squared, 3 cubed, which is 27, minus 36. That will be what? 63, minus 54, minus 63. It will be 9, minus 9. So for sure, will be the absolute minimum. And will be the absolute maximum. So capital M is 7, small m is minus 20. You want capital M plus m, and that will be minus 13, which is this. Yeah, I think I will stop here. Let me stop the recording too. Thank you.